Okay, so we're beginning to look at how to use trig in order to solve for missing sides and angles for triangles that are not right triangles. So we know we can just do the sine, cosine, and tangent for right triangles, but that doesn't work for triangles that are not right, which is what we call oblique. It doesn't make them wrong triangles, they're just oblique triangles. So in this problem, we could not use what we learned on Friday either. We can't use right triangle trig because it's not a right triangle, but we can't use law of sines. Remember, to use law of sines, you must have an opposite angle and side pair given. So on this problem, I have angle C given, but not side C. I have side A, but not angle A. I have side B, but not angle B. You have to have an opposite angle and side pair to use law of sines. So this is a problem that we would be able to use law of cosines on, which is what we're going to learn today. So I want you to look at your discovery sheet, and we're going to go through this together. So just like we did on Friday, we have an oblique triangle ABC that we're starting with. On this one, it draws the altitude for us. It's an altitude starting at vertex C, and remember, altitudes are always perpendicular to the opposite side. So I can put my right angle symbol there since that's an altitude. Now remember, the side across from angle A we're going to call side A, and the side across from angle B is called side B, and the side across from angle C is side C. Well, side C has been separated into two parts, and so if I call one of those parts X, the other part would be found by taking the whole length C and subtracting away that part X. So this is called C minus X. If you add C minus X plus X, you would get the whole length of C. So number one says the altitude is separating our oblique triangle into two right triangles. We're going to use Pythagorean theorem to write two equations. Remember, Pythagorean theorem is for side lengths of right triangles only, but we have two right triangles. And so our first Pythagorean theorem equation is going to be using the KB and the C minus X. So we're looking at this right triangle. Now remember, the Pythagorean theorem is the sum of the squares of the legs setting equal to the square of the hypotenuse. C minus X and K are my legs. When I square C minus X, I cannot write it as C minus X squared this way. If I do, it looks like the only thing being squared is the X. And I don't want just X squared, I want this whole thing to be squared. So remember to put the C minus X in parentheses, squared. And we're going to add the squaring of the other leg, which is K, and set that equal to the squaring of the hypotenuse. So B squared is over here. I'm going to do the same thing with A, K, and X, which are the sides of this right triangle. The legs are K and X, the hypotenuse is A. So I would write X squared plus K squared equals A squared. Here are my legs squared, there's my hypotenuse squared. Now, number two says, notice that both of these equations contain K squared. We're going to solve for K squared, and that just means to get it by itself. So in this equation, if I want to get K squared by itself, I need to get rid of the C minus X squared, which means I'm undoing the addition between them. And what undoes addition is subtraction. And so I'm going to subtract this C minus X squared from both sides of the equation. That will give me K squared by itself. Now remember, subtraction, the order matters, so you have to make sure you get this part correct. You had B squared, and you're subtracting from it the C minus X squared. So make sure that you have the subtraction in front of that binomial squared. Same thing over here. To get K squared by itself, you need to get rid of X squared, which means you're undoing addition. So we're going to subtract X squared from both sides. That will give me my K squared by itself, and the order matters again here. We had A squared that we're subtracting X squared from. So we have gotten both equations set equal to K squared. So now let's move down to number 3. Whoops, that is not number 3. Here's number 3. It says, since both equations in question 2 are equal to K squared, remember that they can be set equal to each other. That's the substitution property. I can replace this K squared with something equivalent. Well, K squared is equal to this. So I'm going to replace K squared with this expression. So I now have B squared minus C minus X squared equals A squared minus X squared. Just setting these two things equal. All right, it says on number 4 to notice that both of these equations still have an x. Remember, x is not a part of our original triangle ABC. X was created when we drew that vertex in. So we eventually want to get rid of x altogether. Okay? Now, the first thing we want to do is we want to expand the quantity c minus x squared. And so that means we want to get rid of the parentheses by doing the squaring of c minus x. Now, a lot of students will incorrectly square a binomial. They think all you have to do is square the terms, and they write it as c squared minus x squared. Well, that is simply not true. That is not equivalent to one another. You can put some numbers in there and test it out and see for yourself that that's not equivalent. When we square something, it means to multiply it by itself. So c minus x squared is c minus x times itself, c minus x. So we have 2 terms times 2 terms. Well, 2 terms times 2 terms is going to get me 4 terms, because 2 times 2 is 4. And so when we distribute, we have to distribute the c times both terms in the other binomial. Well, c times c is c squared. C times negative x is negative cx. We also have to distribute the negative x by both terms in the other binomial. So negative x times c is negative xc, and negative x times negative x becomes positive x squared. Now, you may not notice at first that these really are like terms. Remember, multiplication is commutative, so cx and xc are exactly the same thing. And so we have a negative one of them here and another negative one of them there. And so we can combine those to write that as either negative 2cx or negative 2xc, whichever one you want to write it as. So when we square that binomial, we get c squared minus 2xc plus x squared. That's just the c minus x squared part. So going back to our equation, we have expanded this. But remember, we're subtracting the expansion of it. And so when I write that, I'm still going to put this whole thing in parentheses to show I'm subtracting that entire amount. So in order to get rid of the parentheses, I'm going to have to distribute that subtraction. Or in other words, I'm multiplying each one of these terms by negative 1, which in essence just changes the sign on each one of those terms. So I have b squared minus c squared. Minus a negative 2xc becomes plus 2xc. Minus x squared equal to a squared minus x squared. Now, our goal is to eventually get rid of the x's, which I can't get rid of it altogether, but I do notice that I have a minus x squared on both sides of the equation. So I can at least get rid of that part by adding x squared to both sides. So now I don't have that x squared on each side. I have b squared minus c squared plus 2xc equals a squared. I haven't completely gotten rid of the x, but I'm at least getting there. So in step 5, it says solve the equation for b squared. Remember, that just means to get b squared by itself. So I want to get rid of this minus c squared, so to undo subtraction, I'm going to add c squared to both sides. I also want to get rid of this plus 2xc. Well, to undo addition, we use subtraction. So I'm going to subtract 2xc from both sides. These will cancel. These will cancel. So I will have b squared by itself equals a squared plus c squared minus 2xc. Now, I still have an x in my equation, so I'm not quite to what we call the law of cosines yet. On number 6, it reminds you, you still have an equation that involves x. To eliminate x, we're going to attempt to substitute an equivalent expression in for x. We're going to write an equation involving both cosine of b and x. So let's look back at our original triangle here. Cosine of b is an angle of this right triangle. Remember, I can only talk about the cosine of an angle in a right triangle. Well, if I write the cosine of b, remember cosine is adjacent over hypotenuse. So when I write the cosine of b, I want to use the adjacent and hypotenuse in terms of that b, so in b's perspective. So what is the adjacent side of b? X. So that would be my numerator of my ratio. The hypotenuse is the side across from the right angle, so it is a. So that's what it means when it says to write an equation involving cosine of b and x. When we write cosine of b, it's going to include an x. So we're going to write cosine of b equals x over a, adjacent over hypotenuse. Now, number 7 says solve the equation from question 6 for x. And the reason why we're doing that is, remember, we're trying to find something that we can put in place of x so we don't have it in our equation anymore here. Remember that equation that still contains x. So to get solved for x, we have to get rid of a. So we're undoing division, and to undo division, we're going to multiply. So we're multiplying both sides by a. So now we have x by itself. X is equal to a times the cosine of b. Remember, lowercase and uppercase are really, really important here. A is a side, it's lowercase. B is an angle, it's uppercase. Now, we're going to get rid of the x here because we're going to use substitution. Since x is equal to a cosine of b, wherever I see an x, I'm going to replace it with a cosine of b. So now I have b squared equals a squared plus c squared minus 2, but in place of x, I'm putting a cosine of b times c. So I literally just replaced this x with a cosine of b. Now, I'm going to rearrange things a little bit because that's not how you would typically see the law of cosines. I'm just going to clean this up a bit. This is all multiplication, so those parentheses are not necessary, and I don't want to think that I'm taking the cosine of b times c. The only thing I'm taking the cosine of is b, so I'm going to move the c in front as a coefficient just like a is. So I'm going to write this as b squared equals a squared plus c squared minus 2ac cosine of b. Now you might want to put a little space here between that c and that c of cosine, just so you can tell this is not a variable, that's cosine of b. This is the law of cosines. Now you might think that that looks really, really complicated, but when we break it down, we'll see it's really easy to learn. We're going to use a similar method to write the other two forms of the law for a squared and c squared. This one's solved for b squared. Let's write one that's solved for a squared and another one that's solved for c squared. And I'll show you the pattern here. Whichever variable is squared here, you're going to have the sum of the square of the other two on the other side. So since this is a squared, I'm going to have b squared plus c squared here. Since this is c squared, I'm going to have a squared plus b squared over here. So you have all three variables represented. Then it's always going to be minus 2, and it's going to be the product of the two variables on this side. So you can see it's a times c here. It's going to be b times c here. It's going to be a times b on this one. And then it's always the cosine of the angle that relates to the side on the other end of the equation. So this was side B, this is going to be angle B. This is side A, so I'm going to have angle A over here. This is side C, so I'm going to have angle C here. These are the three different forms of the law of cosines. The next video, I'll show you how to apply it to solving for triangles. If it still looks really crazy, don't despair. I promise by the end you'll have it down.